Namaskar. Tension in a string is our topic today. So this is a type of force, and in dynamics we deal with the forces, different forces, because we know that dynamics is the study of motion in which we have to deal with the cause of motion. Okay, if we know that the cause of motion, that is the motion will be caused by any type of forces, so we will study the types of forces in which are very important in the study of dynamics. So tension is our first type of force we are going to study in this lecture. In the next lectures, and that will be a short type of clips. The types of forces I will separately make some small clips of 2 to 3 minutes or 4 minutes, in which we will deal with different uh, forces like spring force, buoyancy force, magnetic force, electric force, and frictional forces, every different. So in upcoming lectures we will deal with the uh, types of further forces. So in this lecture our topic is tension in a string. So before proceeding to our topic, I have one request to make sure that please subscribe the click on that subscribe button and also the bell icon along with that subscribe button, so that you can get easy notifications for our upcoming lectures. Without time wasting, let us start our topic: tension in a string. So tension in a string is a small concept. This force, which is tension, is a very small concept in which we have to make that force is a type of vector. Na? If force is vector and tension is a type of force, so there will be a direction of tension. Tension in a string is a type of you can that string is a type of cable also, like a rope also, which can be massless or heavy. There are two types of strings: massless or heavy massed. So there will be, if the string is massless, if our string or the cable in which we have to calculate the tension is massless, then tension in that massless string is same at all points. Tension is same at all points. And if we have taken a heavy string, means that of some finite mass, not a massless string, then in that case tension is not same at all points. Tension is variable, or you can say that tension is different at different points. Different points. Tension is different at different points. Sorry, I have written it wrong. Tension is different at different points. This is a small concept, and string can be that we know that string is used to connect two different objects, one object with the earth or one object with any type of pole. String can be used anywhere in our general life. We say that if there are two if we mm, dry our clothes, if we dry our clothes in our houses, then we know that two ends of a string are connected to two type of poles, or you can two pinholes, which at on which that string we dry our clothes. So that string is in the tension. Okay, if we know that there is a mass m, and here is also a further mass m1, this is mass, this is m2 mass, and this is the string, this is our string. The green pen I have used is a string. And further, if we know that m2 is connected with another mass m3, I have assumed it. Okay. So tension will be, the direction of tension is very important. That tension, direction of the tension, I will write direction of tension is always from, tension is always. Are you able to understand it? That direction of tension is always from block to string. So in this string, if I want to write the direction, if I want to show the direction of tension in this string, then direction will be always from block to string. If I want to point the direction of tension at this point, then from block to string means in, from block to string means in this direction. So at this point our tension will be in this direction, and if I want to write at this direction at this point, then from with respect to this block, the direction of tension at this point will be at the in this direction. Similar way, if I want to write the direction at here this point, then this will be in this direction and in this direction. Okay, the direction of tension is always from block to string. This is our main basic concept which we have to focus on. So also I have written that if the string is here, I have written that if string is massless, I have assumed this string is massless, then tension is same at all points. Then this tension at this point, if I assume this is tension T1, then this at this point also the tension will be T1. This will not be different. Another point, we have to assume that if string is continuous also, tension is same at all points. If massless, along with massless, there is one another factor, that is continuous string. Continuous string. Continuous means there is no break in between the string. Here, from this point to this point, the string is continuous. Further, the mass is connected, so the continuity of this string is broken here, and there is another string. So at this point, if in this string, I am rewriting the diagram. If in this string the tension is T1, and in this string, then this is the another string, then in this string the tension will not be T1. Here the continuity is broken, so the tension will not be same, because string is not continuous here. So here will be another tension type. Let us see, let us say this be T2. Okay, so the main point is, if string is massless and continuous, then tension is same at all points, and direction of tension is always from block to string. And string is if heavy, then tension is different at different points. Another concept is that if string is passing over smooth pulley, either in the dynamics we deal with different questions like of pulley also. If I assume that this is a pulley, okay, and this pulley is connected at here, and over the pulley I have assumed a string which is continuous. Okay, I have assumed a string which is connected on both sides with different masses. This is m1 and this is m2, and this is pulley. If pulley is our smooth, that is frictionless pulley. Also, if pulley is our smooth and fixed, another is condition is pulley is smooth and fixed. That is, fixed means pulley is our pulley is not rotating. Fixed means not rotating. Okay, if our pulley is not rotating and smooth also, then tension at both sides of this pulley will be same. That is, the string becomes continuous, and if continuous as well as massless, then then tension over this string will be same at all points. So if I want to write tension here, then this will be from block to string in this direction, that is T, and from in this direct here also the direction will be from block to string in this direction, and tension will be same T. Okay, if this is our assumption, or this is our concept. So, okay, to deal with the questions of dynamics. So in this lecture we have talked about the tension. In the further next lecture I am going to study about the spring force. Okay, so please subscribe the channel and also give a feedback and leave a comment in the comment section, so that I can improve my further lectures. I am trying to teach you in English. I don't know whether my sentences are in order or not, but I am trying to teach you in English because many students request me to teach in English. Thanks a lot. We will meet in the next lecture.